Hey everyone, welcome back. Today, we're going to learn how to build a multi-module project in Spring Boot using Maven. You know, those projects where you can break everything down into smaller, manageable pieces? This really helps keep your code organized and makes your application much easier to scale and maintain. By the end of this video, you'll know how to create a multi-module project from scratch, understand how it's structured, and run it without any problems. Alright folks, let's talk about what a multi-module project actually is, and why it's so useful. A multi-module project is a way to divide a large application into smaller, reusable modules. Each module is a separate project but works together under a single parent project. This allows for better code organization and easier collaboration. Basically, it's like building your application with a bunch of smaller, organized parts. Instead of having one big messy pile of code, you break your app into smaller, reusable modules. Each module is like its own mini-project, but they all fit together under one main project. This makes your code way easier to read, maintain, and scale. Think of it like putting together a puzzle where each piece fits perfectly, and you can work on each piece by itself. This way of organizing your code makes development faster and makes testing and adding new features much easier. Alright folks, let's talk about why using just one project can be a real headache. As you can see on my screen, in a single project, you've got everything mixed together. Controllers, services, DTOs, DAOs, exceptions, basically, all your code in one big pile. Over time, this can become a total mess that's super hard to manage, test, and share. Now, imagine someone just needs your DTOs to use your service. With a single project, they'd either have to depend on your whole project, which can cause problems with other dependencies and just make things bigger, or they'd have to rewrite the DTOs themselves. Not fun, right? This is where multi-module projects come in. By breaking your app into smaller, separate modules, you can share only what's needed, making it much easier to integrate and avoid conflicts. It's like having a tidy toolbox where each tool has its own spot, so you can share just the right tool without all the extra stuff. So, multi-module projects help keep your code organized and easy to work with, and they make it way easier to integrate with other systems. Alright folks, check out this setup. This is what a multi-module project looks like. Each module has its own job to do. For instance, the Employee API module has your controllers and services, which handle all the business stuff and API endpoints. Then, you've got the Employee Common module, which stores all the DTOs and utilities that you can use in any part of your project. And of course, you can keep your DAO layer in its own module, which keeps all your database stuff separate and organized. This kind of structure makes your project way more organized, scalable, and easy to work with. It's like having a super organized toolbox where each tool has its own spot. Everything's easy to find and use. Alright folks, let's talk about why you should consider a multi-module project. There are some compelling reasons to modularize your code. Modularization and separation of concerns. Each module focuses on a specific responsibility, keeping your code clean and easy to manage. Reusability. Modules can be reused across projects, saving you time and effort. Better dependency management. With a multi-module structure, you can isolate dependencies, reducing conflicts and making your project more maintainable. Microservices friendly. Modular projects align perfectly with microservices architecture, allowing you to break down your app into independent, scalable services. Alright folks, let's see how to create a multi-module structure in our project. In our employee service project, we're going to split things up into two distinct modules. Employee API. This module will house all of our service and controller code. Essentially, it's where our business logic and REST endpoints live. Employee DAO. This module will contain all of our DAO layer code, handling data access separately. Alright everyone, let's jump right into creating our first module. Click on the Employee Service project, then select New Then Module. In the Module Wizard, you'll see a field for the module name. Here, type an Employee API. Leave the location as it is. Select Maven as the build system. Ensure the JDK is the same as the parent project. And set the parent to Employee Service as shown on the screen. Click on Create. Watch as IntelliJ builds our new module. Alright, now that our Employee API module is set up, we don't need the auto-generated main class that IntelliJ created. Let's go ahead and delete that main class from the Employee API module. Alright folks, now let's open our parent POM, which is the employee service POM. This file is the backbone of our multi-module project, managing all our modules and dependencies in one central place. Alright everyone, let's take a good look at our main POM file. See that packaging tag? It needs to say POM. This is really important because in our multi-module project, the parent module is like the boss that brings all the other modules together. If you don't set the packaging to POM, Maven won't know that it's supposed to be the main configuration place. So, make sure you have packaging POM/packaging in your parent POM. This makes sure everything works together properly. Alright folks, now it's time to fine-tune our project's dependencies and get our POM files in order. Here's what we're going to do. Spring Boot Starter Web. This dependency is only needed for the web layer, so we'll move it from the parent POM to the employee API modules POM. This way, our parent POM remains lean and only shared dependencies stay there. Log4j. Since Log4j is essential across all modules, we'll keep it right in the parent POM. Data format YAML. We'll move the data format YAML dependency as needed. We'll keep Lombok in the parent POM since it's used project-wide. Keep Spring Boot Starter Test in the parent POM. This way, all our modules will have access to the testing libraries they need. Next up, we're going to move the Jackson data format XML dependency. This dependency is used for processing XML data, and it's not needed globally in every module now. Alright folks, look at that. Our parent POM is now clean and lean. It only contains the essential dependencies we need. Alright everyone, now that our parent POM is looking good, let's add a dependency management section. This is super important because it helps us keep all our dependency versions in one place, so everything stays consistent across our modules. Inside the dependency management section, we'll add a dependencies block. Here, you can import Spring Boot dependencies. But if you're using Spring Cloud stuff, you can use Spring Cloud dependencies instead. Keep the version same as above. Alright everyone, look at my screen. In our main POM file, you'll see the modules section. Here, we've got our employee API module listed. This is really important. Every module you create has to be added to this modules section, so Maven knows they all belong together in our multi-module project. If you forget to add a module here, Maven won't know to include it. Alright everyone, look at the parent section in our main POM file. See how we've set the parent to Spring Boot Starter Parent? This is really important because it makes sure all our child modules get the standard settings, dependencies and plugins from Spring Boot. Now, check out our employee API module. It's set to inherit from employee service. What does that mean? It means employee API gets its settings from employee service, and because employee service gets its settings from Spring Boot Starter Parent, everything's connected in a nice chain. This way, all our modules use the same Spring Boot best practices and stay consistent. Set our Java version to 21. Alright everyone, we want to make sure everything in our project is using the same version. So, we're going to set the version for employee API to be the same as our main module. This makes sure all our project parts are using the same Java version and dependency settings. Watch as I change the version in the employee API POM on my screen. Alright, now we're going to put all the code where it belongs in this module. Follow along as I move things around so that all the important code is inside this module, making our project much cleaner and easier to work with. Now that our code is neatly organized into modules, let's tidy up further by moving all our resource files and test files into the appropriate module. Alright folks, now that we've moved all our code, resources and tests into their respective modules, it's time to clean up our parent module. Since the parent module is just serving as an aggregator, we don't need its src folder anymore. Let's delete the src folder from the parent module to keep everything lean and tidy. Alright everyone, now that we've got our Employee API module ready, let's add another important part, the Employee DAO module. Just like before, we're going to make a new module, but this time it's just for our database stuff. This keeps our database code separate and makes our project even easier to manage and work with. Alright everyone, check out the modules section on my screen. You'll see that IntelliJ automatically added our new Employee DAO module.
Cool, right?
But if for some reason it's not showing up in your project, don't worry, it happens. Just remember to add your module manually to the parent POM to make sure everything's linked up correctly. This is super important for keeping our multi-module project organized and working properly. Alright folks, now it's time to keep everything in sync. Set the Java version and the module version in Employee DAO module. Alright everyone, let's say you've got a common module where you keep all your shared stuff, like utilities or configurations, but it doesn't need to do anything with the web. In that case, you don't need to include the whole Spring Boot Starter web package. You can just add Spring Boot Starter. This gives you all the basic Spring Boot things, like dependency injection and auto configuration, without adding all the extra web stuff, which keeps your module small and fast. Alright folks, now let's simplify things for our DAO module. For data access, we don't really need the entire Spring Boot Starter dependency now, so we're going to remove that dependency from the DAO module's POM file. This way, we leave room to later add a more targeted dependency if needed. Alright everyone, we've got our multi-module project all set up, and both our modules are ready to go. Now it's time to see it all come together. Let's start the application and watch our REST APIs work their magic. Alright, our application is up and running perfectly. Now, let's switch over to Postman and hit our API endpoint. Look at that, check out the response on my screen. Everything is working just as expected. Great job, everyone. Alright everyone, wow, what a great session. Today, we built and configured our multi-module project, got our Employee API and Employee DAO modules all set up, and made sure our REST APIs were working perfectly with Postman. Everything's running smoothly, and our project's looking super organized and ready to grow. Thanks so much for hanging out with me. If you liked learning about multi-module projects, please hit that subscribe button and ring the notification bell so you don't miss any of our upcoming videos. Can't wait to see you next time.